Today we're going to be talking about the ear. We already did the first part. Now we are doing part B. Let us review what we learned last week. We learned that ears are organs of sound, that ears are divided into three areas: outer ear, middle ear, and inner ear. And the sound travels from the pinna through the ear canal where it hits the eardrum. And from there it travels through three tiny bones into the cochlea. The cochlea has tiny hairs in it that translate the sound into nerve signals. And the nerve signals travel through the auditory nerve to the brain. So this is the diagram that we studied last week. We studied the pinna, which is the outer ear, and then the ear canal, which is there, and then those are the three little bones that go from your eardrum to your cochlea and travel through your cochlear nerve, right? And these are the new ones we are learning about today. These are the semicircular canals. I know we mentioned them the last time, but now we're just going to go over it again. Okay. Keeping balanced. Many parts of your body help you to keep balanced. Your eyes tell you about the position of your body. So do sensitive cells known as stretch receptors in your muscles and tendons. The vestibular system in your inner ear also has an important part to play in maintaining your balance. It has two main areas: three loops called semicircular canals and two sacs called the utricle and sacucle, whatever that is. So there is your vestibular system, and this is your semicircular canals. Can you see how there is 1, 2, 3 of them? And there's your two sacs there and there. The semicircular canals contain fluid-filled tubes called semicircular ducts. At the end of each duct is a small swelling which has a gel-like projection called cupula inside. You see there's the cupula there. When your head turns, the fluid moves more slowly than the head, bending the cupula back. Tiny hair cells at the base of the cupula send your brain information about the rotation of your head. So these little hair cells over here send your brain information. Those ones there. Okay. The utricle and saccule contain a small gel-like patch called macula. It contains tiny grains called otoliths and hair cells. When your head moves, gravity causes the otoliths to slide to one side, pulling with them the gel and the hair. So there's the otoliths that gets moved by the gravity, and this pulls the tiny hairs, and these hairs are then connected to what? Yes, they're connected to nerves that travel up to your brain. These send you information about the forward and backward and sideways or tilted position of the head. You have two ears. Having two ears gives your brain two sources of information about sounds, movement, and position. By combining this information, the brain finds out more than it would from one ear alone. For instance, having two ears helps you to tell from which direction a sound is coming from. A sound coming from the left will hit your left ear slightly earlier than your right and will produce stronger vibrations. If the sound is directly in front of you or behind you, the sound arrives at each ear at the same time and the same volume. Let us review. The vestibular system helps with balance. The semicircular canals are 3 loops, and they contain the semicircular ducts and the cupula. And the semicircular ducts are filled with fluid-filled tubes, and the cupula has a small swelling with tiny hair cells that sends information to the brain. And then underneath the semicircular canals, we have the utricle and saccule, which are what? They are 2 sacs, and they contain the macula, which is a small gel-like patch. The othellus is the tiny grains, and the hair cells. And they also send information on your position of the head. And then we also learned that sound may reach our 2 ears at different times. And we know this, right? If you're sitting straight and you can't see anything, you know who's talking, the person to your left or the person to your right. You can hear it because if the person to your left talks, the sound waves come to your left ear faster.